So what will be the effect of rule simplification? The first thing is rules are no longer mutually exclusive, because your mutually exclusive principle said that a record must not be triggered by more than one rule. But once I simplify the rule, a record may be obviously triggered by more than one rule. So mutually exclusive principle is gone with respect to rule simplification. So what I'm supposed to do for this, I'm supposed to go for ordered rule set. Now what is ordered rule set? We'll discuss that later, but in a simple sentence, what is the ordered rule set? It is the ranking of rules based on its accuracy or rule coverage. That is what we do when the rules are no longer mutually exclusive. Or we go for unordered rule set, wherein we use voting schemes. We discussed an example, 2 times amphibians was appearing, so I took the class label as amphibians. That is what I call it as voting. And your rules are no longer exhaustive. A record may not trigger any rules. We were saying at least one should be triggered, but now with the process of rule simplification, a record may not trigger any values. So what is the solution for this? Use a default class. So what are those concepts? We'll discuss later. This is with respect to rule simplification and the effect of rule simplification. Now we'll see what's a ordered rule set. Why are we going for ordered rule set? If the rules are no longer mutually exclusive because of rule simplification, we need to find a solution for it, and the solution is ordered rule set. So we are looking into the topic of ordered rule set. Here rules are ranked according to their priority. Ordered rule set is known as a decision list. Don't get confused with respect to decision tree. An ordered rule set is known as decision list, and these rules are ordered as per the rule accuracy or rule coverage. So when a test record is presented to the classifier, it is assigned to the class label of highest rank rule it has triggered. If none of the rules are fired, then it is assigned the default class. What is that? We'll see an example here. I have 5 records, R1, R2, R3 up to R5. Fine. So I have 5 rules and I have a new instance. The name of the animal is turtle, and I'm supposed to find the class. To which class will it fit? Whether it will fit into bird, fishes, mammals, reptiles, amphibians, etc. I'm not sure. I'm supposed to apply this record and see whether any of the given rule covers this instance. Fine. So we look at the first record. Gives birth is no, and if it can fly, then I'll classify it as bird. I'll see. Gives birth is no. Yes, obviously this condition is matching. Can fly is yes, but can fly for this new instance is no. So rule R1 will not cover this instance. We'll go to rule R2. Gives birth is no. Yes, it is matching. Lives in water is yes, but lives in water here it is sometimes. So R2 also will not cover this instance. We'll go to R3. Gives birth is yes. Gives birth is no. It is not matching. So the conjunction condition is not matching. So even R3 will not cover the given new instance turtle. We'll go for R4. Gives birth is no. Yes, gives birth is no. Can fly is also no. Yes, can fly is no. Then it will be classified as reptile. Fine. So R4 is triggering the new instance turtle, wherein gives birth is no. Yes, gives birth is no is matching, and can fly is no. Yes, it is matching. Reptiles, it will be classified as reptile. We'll go to R5. Lives in water is sometimes yes. Lives in water is sometimes. It is getting classified as amphibian. Then there is a conflict here. You might ask, sir, how can a same 2 different rules trigger a same instance? Fine. That is the problem with respect to your rule simplification. Now in this case, rule R4, what is happening? 2 attribute conditions are getting matched for a new instance, but whereas in case of R5, only one instance, one attribute condition is matching. What is it? Lives in water sometimes, lives in water sometimes. Only one is matching. But whereas in this rule 4, R4, gives birth is no, gives birth is no, and can fly is no, can fly is no. 2 conditions, 2 conjunctions are getting satisfied. Hence the class label will be given as reptiles but not amphibians. So the number of conditions covered by a rule will be considered. That is what I call it as ordered rule set. I said rule coverage or rule accuracy. Rule coverage is 2 antecedents are getting covered, but whereas in this case only 1 antecedent is getting covered or 1 attribute condition. So I'll only take R4 but not R5. Fine. So this is with respect to your ordered rule set. Now we'll see what are the rule ordering schemes. We have 2 schemes. One is the rule based ordering, the other one is the class based ordering. Wherein your rule based ordering, individuals are ranked based on their quality. I repeat, in case of rule based ordering, the individual rules are ranked based on their quality. And how we define quality? Based on its coverage or the accuracy. I can say a given association rule is strong or weak based on its confidence and support values. Similarly, the quality of a rule can be based on either its accuracy or coverage. So individuals are ranked based on their quality. This ordering scheme ensures that every test record is classified by the best rule covering it. Fine, which is the best rule based on the quality. A potential drawback of this scheme is that lower ranked rules are much harder to interpret because they assume the negations of the rules preceding them. So the drawback as written here, once I start ranking the rules, the classification rules based on their quality, so based on their accuracy, lower accuracy rules will assume the negation of the preceding one. Since the previous rule has already covered the antecedent and consequent, the next rules will not be able to cover that. That is the drawback. So here I have given an example. What is the rule based ordering? Based on accuracy. So I have just directly noted it here. How to calculate rule coverage and rule accuracy we have already discussed. So based on the quality, based on the rule coverage and accuracy, I have listed the rules here. Next we have class based ordering. In case of your class based ordering, rules that belong to the same class appear together. Read the sentence. In case of your rule based ordering, individual rules are ranked according to their quality, rule coverage or accuracy. But whereas in case of your class based ordering, rules that belong to the same class appear together. That means if your target function is having same class, then they'll be put together. Or say for example, if students are interested for any orientation program or any workshop, all those interested students will be put into one group. Not interested students will be in another group. That is what we call it as class based ordering. Rules that belong to the same class appear together. The rules are then collectively sorted on the base of class information. That means how many attributes it is covering, they will be sorted. The relative ordering among the rules of the same class is not important. The only thing that is of matter or concern is whether the given rule will trigger a record or not. Whether they first write positive classes or negative classes, or first negative classes then positive classes, it is not of concern. We'll see an example here. Fine. First I have written negative, no, no, no. So these are having same class. What is that class label? No, no, no. I have grouped them together. Only one rule is having the target function as this. I have made it a separate row. So whether I write all the rules with no as the class label first or with yes as the class label first, doesn't matter. The ordering with respect to class based rules is not of concern, but only thing, every class based rule should trigger a record. That is of much importance. So this makes rule interpretation slight easy because I have classified or grouped the classes or the the classification rules. However, it is possible for high quality rule to be overlooked in favor of inferior rule that happens to predict higher ranked rules. So even in case of your class based ordering, I can still determine the rule accuracy and coverage. So when I have just clubbed positive classes together, negative classes separately, there might be a mix of high quality rules as well as low quality rules. That is the drawback of your class based ordering. I have given the same example here to just differentiate what exactly is rule based, class based according to the rule accuracy and coverage. I have listed here based on the class label. No, 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 I have listed. Now we have one more example here again for rule based ordering as well as class based ordering with respect to the vertebrate data set that we have discussed in the very beginning class of your module 4 classification. Fine. So according to their rule coverage and accuracy, here you can see the class label is bird and it is bird. It is group 1. Mammal is only one instance, so I have written it separately. Again, amphibians is appearing twice. I have written it as one group. Here reptiles and fish is only single instance. I have separated them. Fine. So basically class based is target functions or class labels having same class value are grouped together. Rule based on the rule coverage or accuracy, they are grouped together. Fine. Next we'll see how to build classification rules. There are two methods. One is the direct method, the other one is the indirect method. In case of direct method, rules are directly extracted from the data set. I repeat, in case of direct method, rules are directly extracted from data set and in your syllabus we are supposed to cover two algorithms. The first one is sequence covering algorithm, the second one is the Ripper algorithm, and we have the second category of extracting classification rules in that is called as indirect method, wherein the rules are extracted from classification models, and examples are decision tree, neural network, C4.5 rules. In your syllabus only we are supposed to discuss about decision trees. So basically if I extract rules from the data set directly, it is called as direct method. From the data set I construct a classification model. From that classification model if I extract the rules, it is called as indirect method. So now we'll see the first method, the direct method, wherein I make use of the sequential covering algorithm. So there are 4 steps in case of your sequential covering algorithm. So please remember, direct method is the process of extracting rules directly from the data set, and the very first algorithm that we are supposed to discuss is sequential covering algorithm, and it has 4 steps. What are those? First step is start with a empty rule or a null set. Fine. So start with an empty rule, then start growing the rule set using the concept of learn one rule function. I repeat, you start with a empty rule, then you start growing the rules by using the concept of learn one rule function. What is that learn one function? Learn one rule function, we'll see. Remove any training records covered by the rule. So once a record is covered by the rule, you are supposed to eliminate it and then move for the second record. So repeat step 2 and 3 until stopping criteria is met. What is that stopping criteria? We will discuss. So as of now, these are the 4 simple steps with respect to your direct method, and this major part of your 4-step process is the learn one rule function. So I said the major part of your sequential covering algorithm is the learn one rule function. So to understand the sequential covering algorithm, first we'll look at the learn one rule function. So what is that learn one rule function? We have a data set here consisting of positive instances as well as negative instances. Please look at the diagram keenly. This is the data set. Fine. I have represented the class labels. There are 2 class labels, positive and negative. So that is what I have given in this boundary. This is the original data set, and I am supposed to apply learn one rule. And what exactly is the learn one rule saying? A rule, if it can cover more number of positive instances and 0 or few negative instances, that is the learn one rule function. So I repeat, what is the learn one rule function? A function that covers more number of positive instances or 0 or few negative instances. Fine. So in a simple sense, say for example, when a teacher teaches a concept, right, what is the objective? The objective of the teacher is that more number of students understand or 0 or few students don't understand. Fine. So the objective is simple. I explain a concept, everyone understand, or there are 0 or few students who have understood it. The same thing is your sequential covering algorithm with respect to learn one rule function. A function that covers more number of positive instances and 0 or few negative instances. So if that is the concept, then I'll group them as one group and I'll make it as rule R1. So in this diagram you can look at the first step is cover now more number of positive instances. Yes, I'll be able to cover 1 2 3 4 5 6 positive instances, and I'll group it and I'll make this as rule R1. That is what I've done. I'll move to the second part of the diagram. Fine. I find more number of positive instances. I'll cover this. I'll make this as rule 2. Then I'll cover this part. It is covering 4 instances. Again, that will be my rule R3. That is what I've done here. Fine. You can repeat the same process. This is your learn one rule function. A function which covers more number of positive instances and less number of negative instances. Even if it is 0, fine. So in the first case, what I have done, I have covered only positive instances, 0 or few negative instances, no negative instances here. But in this case, what I have done, I have covered 2 negative instances. So 0 or few negative instances. So please listen to this. I am repeating this probably for the 4th or 5th time. Any function that covers more number of positive instances and zero or few negative instances, positive, negative or zero, then it is called as learn one rule function, and this function is used in your sequence covering algorithm. And now we look at the algorithm itself. So this is the algorithm for your sequential covering, which makes use of learn one rule. Fine. So what is the first step? Let E be the training records and A be the set of attribute value pairs. Obviously, if I am supposed to apply for a data set, there will be n number of instances. I represent it as E, and every instance will have some attributes and their attribute value pairs. So I represent attribute starting from 1 to j, and every attribute will take some values, either binary, discrete or continuous, and those values are denoted as Vj. Let y0 be the ordered set of classes. So your every record will have some class label starting from y1 to yk, that is represented as an ordered set y0. Let r be the initial rule set. That is what I said, the first step of your sequential covering algorithm. What is it? Start with a empty rule, then apply learn one rule function. So I'm starting with a empty rule for all those instances and the class target. Unless and until the stopping condition is not met, apply learn one rule. What is the learn one rule? We have just discussed with an example. Cover more number of positive instances and zero or few negative instances, and once you cover, I mark it as rule 1. So that becomes my rule. So assign it as a rule, and remove the training records. So I've covered some positive instances, right? Remove all those instances from the record. Why? Because mutually exclusive principle. No record should be triggered by two rules. So one record has already triggered some positive instances, so remove that records, and then add r to the bottom of the rule list. I have started with empty, add it to the bottom, so that if the next rules come up, they will be placed on it based on the rule accuracy or coverage. And I'll complete this. How long will I repeat this learn one rule? Unless and until further there are no positive instances or negative instances left to cover. That is your stopping condition. Unless and until this stopping condition is left, keep on repeating. So your sequential covering algorithm is very simple. You start with an empty set, then cover more number of positive or negative instances. Any instances covered will become a rule. That rule should be eliminated and added to the bottom of the empty rule set. Then keep on repeating the process. How long? There are no more further positive or negative instances. Then you'll stop executing your sequential covering algorithm. This is the direct method for extracting rules from data set. Next we have the aspects of sequential covering, and in that we have rule growing, instance elimination, rule evaluation, stopping criteria and rule pruning. But in your syllabus they are only mentioning about rule growing and rule evaluation. We'll see the two approaches for rule growing and rule evaluation, just like how we evaluated your models as well as association rules using various measures such as lift factor, the confidence support, interestingness measure, correlation analysis. The same thing is supposed to be done for your classification rules. That is your rule evaluation, that we will discuss in the next video lecture. But as of now, to conclude for this video session, we will discuss about rule growing. And your rule growing is commonly divided into two common strategies. One is the general to specific, the other one is specific to general. And if you can recollect, we have discussed about general to specific, specific to general in the methods for your frequent item set generation. Frequent item set can be generated using a priori algorithm and your FP tree algorithm, and the alternate methods to generate frequent item sets is your generic to specific as well as specific to general. The same concepts are used for rule growing. What is rule growing? You start with an empty set, then you go on adding rules. That is what I have done in case of your generic to specific. Now whatever sequential covering algorithm we have discussed, it is the example for generic to specific. We start with empty rule set and then we go on adding rules. So this is an indication. Refund is no. There are 3 positive instances, 4 negative instances. Wherever refund is taking the attribute value pair, no. Similarly, status is single. There are 2 positive instances, 1 negative instance. Basically, start with an empty rule set, then go on adding rules. That becomes generic to specific. That is your sequential covering algorithm. The other approach is specific to general. The name itself indicates specific. You have the attribute value pair. From that you start generating the rules. So what are the specific attributes I have, conditions I have? Refund is no, status is single, income is 85k, then the class label is yes. So there are other possibilities where refund is no, status is single, but still income is 90k, class label is yes. So first two attributes are matching, but the third attribute condition, income is 85k, here it is 90k. So if I combine these two, then the common thing is class label is yes, refund is no, status is single, refund is no, status is single. I can classify or simplify the rules wherein income can be excluded, and directly I can write the class label as class is yes. This is called as specific to general. So I hope in these two video lectures we have discussed about your rule based classifiers as well as your sequential covering algorithm and the process of extracting rules with respect to the direct method. In the next classes we will discuss about the indirect methods as well as rule evaluation, how to measure a given rule, which is the best rule that we can do it using your rule evaluation, and we will discuss about indirect methods. So thank you.